Good afternoon, class. It's the spring semester of 2020. We're at College of the Sequoias in the Central Valley of California, and we're in COVID-19 lockdown, but the show must go on. So this is Math 154 Trigonometry, and right now in Chapter 8, we are looking at oblique triangles. In 8.1, we looked at Law of Sines. 8.2, we're looking at Law of Cosines. This will allow us to do our other cases. Recall Law of Sines helped us with the side angle angle, angle side angle, or side side angle. And Law of Cosines, we're going to be using this one for side angle side and side side side. So in this one, we have two given sides. And the angle between the sides. Like that. Or all three sides. So we could complete the triangle there. This would give us little side A over there, angle B, angle C here. Here we're missing angle A, angle B, angle C. So the law of cosine, the derivation is a pain in the butt. It really is. It's a big pain in the butt. Pain in the ass. So let's just write out what the formulas are. It's more confusing than just giving you the formulas, because the formulas are all pretty straightforward. In each case, we have almost effectively the Pythagorean formula, just little slight variations. And then whichever side we got squared, we add the squares of the other two sides, and then we do minus 2 times each of those sides times the cosine of that angle or that side over there. Here we're going to subtract 2 times A and B, and we're going to do the cosine of that angle over there. Let me see if I can start the download for 8.1 so we can get it up on YouTube. Is that what you're telling me? It is what you're telling me. Let's get that download started real quick so we can get it up for you right away. This is how Zoom works. I got my account information here. My recordings are all stored in here. This is the meeting we're working on. This is the one we just did. This is 8.1. Look at it, it's an hour and 45 minutes. And now we'll get back to the show that we're working on. So notice let's just look at this last one right here. If angle C equals 90 degrees, then cosine C equals cosine of 90 degrees. And that equals what? 0. Which turns this into C squared equals a squared plus b squared. We know that formula. That's the Pythagorean theorem. The Pythagorean theorem is just a subset of the law of cosines. And they're really that you just have to memorize them. Whatever side you got squared, you add the other two squares to the other two sides. And then you've got this thing going on here. Just remember the two sides you're multiplying are the sides that are squared on this side. And then you're going to do the cosine and the angle on the opposite side. Okay, let's work through some examples. This section is a little bit shorter than the law of sines because law of sines has that tedious part with the options. Let's take a look at where angle C is 122 degrees, B is 250 meters, and A is 420 meters. Let's find side C. Okay. Drawing a picture is always handy. Looks like angle C is obtuse. It's wide. It's bigger than 90 degrees. This is the side that we're looking for. If I call this A and B, then this is 420 meters. This is 250 meters. So which formula looks best? We've got them up on the screen. You can see them right here. We have, what do we have? Let's do our table. We have side A and B and angle C. Which formula has that information? This one corresponds with C squared. We need the one that has angle C in it. So C squared equals A squared plus B squared minus 2AB cosine C. Use the formula with the angle. Plug in what we got. 420 meters squared plus 250 meters squared minus 2 times 420 meters times 250 meters times cosine of 122 degrees. Or 20 squared is that's 176,400. Let's see what 250 squared is. $62,500. And then minus, we'll have 2 times 420 times 250 times cosine of 122 degrees. minus 111, 283.0455. All right, I'm going to do 176, 400 plus 62,500 minus answer. That's how my calculator works. C squared equals 350,183.0455. We'll take the square root. And I don't think I should have it any more precise than the other sides of the triangle. So what do you think, 592 meters? Yeah, let's go 592 meters. And then if we want, what would we do to find angle A and B? Use law of sines for the smaller angle. The smaller angle has the smaller side. Why do we choose this? The smaller angle cannot be obtuse. It has to be less than 90. And so no two triangle option. Okay. Hold on a second. Yeah, the law of sines, we had to calculate another angle first. And calculating the other angle first gave us variance. We could have ended up with a big angle or a small angle. If you calculate the, because this is side-side angle, that's similar to sine angle side. We had one angle, two sides. The other one, we had to calculate another angle first. Law of cosines allows us to use for side-side angle to find the third side and then be smart about this. I hope this makes sense. Try to think about that. Let's say angle A is smaller. If it's above 100 or 100 above 90 degrees, that means angle B has to be above 90 degrees. But angle A, B, and C have to add up to 180. If A and B are already bigger than 90 each, we're already above 180. C can't be a negative angle. Not on a triangle. Okay? Take a look at another one. So an example, you guys give this a try. A equals 43.2 degrees. B equals 13.4 meters. C equals 16.2 meters. Solve the whole triangle. Find the remaining parts. I recommend pausing it here, draw a triangle, fill in what you know, use the law of cosines to find the third side, and use that argument I just presented. Okay, if you hit pause, let's go over what we have. Let's call this triangle ABC. A is not that big of an angle. I don't know if B or C is a big angle. I have no idea about the rest of the triangle. Let's just, I don't know. ABC. 43.2 degrees. 13.4 meters. 16.2 meters. I'm going to make my table so I can track my stuff. I have A is 43.2 degrees. B is 13.4 meters. C is 16.2 meters. This looks like I have to do the one where I'm solving for A first. So that's going to be my left side. A squared equals, it's the sum of these two sides squared minus 2 times the sides times the cosine of the angle opposite, the third side. So let's see, 13.4 squared is straight up, no rounding, 179.56. 16.2 squared is 262.44. Then we're going to subtract. Minus 316.489. We'll round to 49 for now. Now let's go to 489. We can always round at the end more. 4890. This is all in meters squared. I didn't point that out earlier. I should have. Now when we take the square root of both sides, well, let's finish calculating that. So 179.56 plus 262.44 minus my answer. Now we'll take the square root. What the hell? Ooh, I multiplied. 200 and 250 minus 300 should not give me 46,000. That doesn't compute. Did I enter everything right? Let me do this again. 13.4 squared plus 16.2 squared minus 2 times 13.4 times 16.2 times cosine of 43.2. A squared is 125.5109807. Looks like I rounded in my notes that I'm using before. That's in meters squared. And the square root of meters squared is meters. And we'll round this to 1 decimal place. A is approximately 11.2 meters. Looks like this green pin's dying. Want to toss it. Grab a new one. I got pins for days. So 11.2. Now what do we do? Which of these angles has the smallest angle? So B is less than C, which means B degrees is going to be less than C degrees. So we're going to solve for B. So we've got sine B over B is 13.4 equals sine A oh, I need another line. Which equals K. So B equals sine inverse. Or approximately 55.0 to 1 decimal place. You do not need law of sines to find side C or angle C. C equals 180 minus 43.2 minus 55 degrees. $81.8. Okay. So choose the smaller side. Which guarantees a smaller angle. Which means that angle has to be less than 90. This avoids looking for a second triangle. If we had done the bigger one side first, it would have screwed us up. And finally, we have the side situation. So for case 4, side, we're gonna find the largest angle first. using the law of cosines. How do we do this? Put the biggest value by itself. Now, the good thing about this is it doesn't matter whatever that angle is. I don't know if it's A, B, or C, so let's say theta. If cosine theta is less than 0, it's an obtuse angle, which means theta is greater than 90. And if cosine theta is greater than 0, it's an acute angle. So theta is less than 90. In any case, it's the largest angle. Which forces the other two angles to be acute. So let's look at an example. So side, 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 find the largest angle. So we're going to go A equals 10.32 feet. B equals 16.2 feet. C equals 23.4 feet. This is the largest one. So we're going to use C squared equals A squared plus B squared minus 2AB cosine C. Even before I plug stuff in, I can make it so I just do it all at once in the calculator. Let's subtract A squared and B squared from both sides. We divide by negative 2AB. You can either use it like this, or you can move that negative up to the top. Take your pick. I'll just go with the first one. C squared is 23.4 squared. And remember, our outcome is going to be, we'll see what it ends up with. Actually, I better put the units. 23.4 feet squared. And then I've got minus 10.32 feet squared minus 16.2 feet squared divided by negative 2 times 10.32 feet times 16.2 feet. Looks like we've got feet squared on top, feet squared on bottom. It goes away, which makes sense. Cosine of a C is just a number. What do I get when I do that? Do parentheses, 23.4 squared minus 10.32 squared minus 16.2 squared. I'll end parentheses. Now hit divide and then do parentheses again. Negative 2 times 10.32 times 16.2. end parentheses. So this is negative, which tells me C needs to be greater than 90 degrees. Okay? And it is. The smallest number of decimal places now let's go 3 decimal or 1 decimal place. We should probably go down to just 3 significant digits. You've got C equals 122.28, or C equals 120. I just said 1 decimal place. Okay, so what do we've got so far? We just found C to be 122.3 degrees. And now I know the both remaining angles are acute. It doesn't really matter which one I go for. I'll just keep going down in largest to largest, or next largest to next largest. Let's find B next. So sine of B over B equals sine of C over C. That's going to equal K, which is 0.5851811269. So B equals sine inverse of K. And we're going to 1 decimal place. So I'll go back up, fill that in on my chart. I don't have to worry about a second angle because C is already bigger than 90 and C was the biggest degree. And finally, A equals 180 degrees minus 35.8 degrees minus 122.3 degrees. (21.9 degrees). And there's salt. Okay. So this shows up in architecture and carpentry a lot. Let me show you where. If we've got a roof, this is making a whole bunch of triangles. We got a triangle back there. And it keeps going the whole way. These are called, here, the triangles are called roof trusses. So to get them to fit seamlessly, they already know the lengths of the sides. From blueprints. They just need to know what angle to cut the wood at. Quick example. I'll do the side profile now rather than trying to draw a 3D. And this will be 9 feet, 6 feet, and the bottom's 11 feet. And let's just start off. We'll find angle C. I think this shows up in one of your problems, this like in MATLAB. And from there, if when they would go on to find the other angles. Should we find angle C though? Should we? No, that's a bad idea. Why? Why is finding angle C the bad idea? I told you you should go with the largest side. Let's find angle A. Now I'll just plug in what I know. A is 11 feet squared. We already know the units canceled out. We saw that in the last problem. So 11 feet squared minus 6 feet squared minus 9 feet squared over -2 times. Why did I say AB? This should be BC on bottom. 6 times 9. That's 121 minus 36 minus 81. Over 6 times 9 is 54, -108. Cosine inverse of -4 divided by 108. So A is approximately 92.1 degrees, just a little bit above a right angle. Then go on that. Why don't you guys try it right now? Find B and C. Okay. So 11 over sine of 92.1 equals B. 6 over sine of B. Sine of B equals 6 over 11 times sine of 92.1. Zero 0.545088214. And we do find B with sine inverse. And C is going to be 180 minus 92.1 minus 33. .9 degrees. Voila. So there's another example of law of cosines. This is an application. So let's recap of what we did in the last two sections. Okay. So solving oblique triangle strategies. And it all depended on what case we had. Case one was side angle angle or angle side angle. And what did we do there? Step one, find third angle with A plus B plus C equals 180. And then law of sines for remaining sides. Case two was our potentially fun one. Side-side angle. And in this case, we know one angle, but not the included angle. Included is side angle side. What did we do here? So we had to find an angle with law of sines. Then we used the angle sum formula, which is that. Then find the last side with law of sines. And this was the case where we had to check for a second triangle. And if there is a second triangle, repeat 2 and 3 if necessary. Then we had case 3, which was the side angle side, or the angle is the included angle. Here we found third side with law of cosines. Then law of sines for the smallest remaining angle. And then the angle sum formula. And finally, case 4, side, side, side. So no angles. So here, find largest angle with law of cosines. And then second angle with law of sines. And the third angle, you always want to use the angle sum formula. So one final thing, I think they throw it in here just to show you. Yeah, I would never test you on this, but it's neat. It's a neat like trick way of finding the area of a triangle. So let's take a look at it. It's called Herons area formula. And sometimes it's called Heroes. I don't think they know for sure what the guy's name was. So given A, B, C sides of the triangle, the semi-perimeter is called this. Goes by S. It's 1/2 the sum of the sides. I'm not sure why it's called semi-perimeter. It sounds like half the perimeter to me. I guess semi can be half. I guess, yeah, semicircle is half a circle. Okay. Then the area of the triangle is given by this. It's the square root of S times S minus A times S minus B times S minus C. No, you won't be tested on this at all. It's just neat. So an example. A equals 13 meters, B equals 8 meters, C equals 18 meters. Find the area of triangle ABC. So we start off by computing S. S is 1/2 times 13 plus 8 plus 18. That's 19.5. And then we needed S minus A, S minus B, and S minus C. 19.5 minus 13 is 6.5. This is meters. 19.5 minus 8 is 11.5 meters. And 19.5 minus 18 is 1.5 meters. The area of the triangle is the square root of 19.5 times 6.5 times 11.5 times 1.5. Each of these has meters in there. So what do we get on the inside? 2,186.4375. This was in meters to the fourth. And when you take the square root, we get 46.759. The square root of meters to the fourth is meters squared. If we want to take it down to 3 decimal places, like we had the 3 S minus A's, 46.8 meters squared. Or you could go all the way down to 47 meters squared. All right. So that wraps up 8.1 and 8.2. We'll be doing a few more sections in this chapter. All right. Peace.